Section R.4, Factoring. Factoring polynomials is the reverse of multiplying polynomials. In the problem below, I've got x plus 4 times x minus 6 is equal to x squared minus 2x minus 24. Okay, in the last section in R.3, we went from this left-hand side and did FOIL to get the right-hand side. In this section, R.4, the factoring section, we're going from the right-hand side to the left-hand side. Now, the terminology that goes with what we've set up there. Number 1, x plus 4 and x minus 6 are called factors of x squared minus 2x minus 24. Number 2, the written product of the factors, x plus 4 times x minus 6, is called the factorization of x squared minus 2x minus 24. You could also have written it as x minus 6 times x plus 4. That would also be the factorization. Notice that the factors x plus 4 and x minus 6 cannot be written as the product of two other polynomials other than themselves and 1 or minus 1 using integers. Number 3, x plus 4 times x minus 6 is called the complete factorization of x squared minus 2x minus 24. Since x plus 4 and x minus 6 cannot be written as the product of two other polynomials other than themselves and 1 or minus 1 using integers. Okay, we're typically going to use integers or at worst rational numbers. We don't use irrational numbers when we factor. Number 4, when factoring, we always factor completely. So whenever the directions say factor, that means factor completely. So don't stop in the middle. If it can still be factored, you got to keep going. So even if you don't see the word completely, it will always mean factor completely. So we're now going to look at some basic factoring techniques. Now, unfortunately, in the world of mathematics, factoring is one of the few places where trial and error actually is a technique. So we're going to try to arrange our techniques so that they make a little bit of sense, and we're going to try to go in a logical pattern. So the first technique, factoring out a common expression. Okay, the book sometimes calls it a GCF, or you may see that written someplace, GCF, greatest common factor is what that stands for. So GCF means greatest common factor. We always try to factor out the greatest common factor. So this is really just the descriptive property in reverse. So you're going to try to put something outside parentheses and then figure out what goes inside the parentheses. For numbers, you want to factor out a number that will divide evenly into all of the coefficients of the terms. Now, sometimes there is no number to factor out other than 1. So if there's only the number 1 to factor out, we usually don't write it. For a variable that is common to all of the terms, the largest one that you can factor out is the one with the smallest exponent. So if the first term, say, has an x squared and the next term has an x cubed, the one that you can factor out, the largest factor you can factor out, is the one that says x squared. So always take one with the smallest exponent for common variables. So factor each of the following. Now again, note, factor always means factor completely. So first one, I've got 7x minus 7y. Okay, now I've tried to make it obvious what they have in common. Okay, they have the number 7 in common. They have no variable in common. So I'm going to factor out the 7. Okay, to figure out what's left inside the parentheses, again, this is kind of overkill on this one, just divide each one of these terms by what I'm putting in front of the parentheses. So I'll be left with x minus y. So that's our complete factorization. And notice you can check the factorization by multiplying it back out. Because we always say that with factoring, that you can always check it by multiplying it out, but we usually don't do it. But it's kind of a good idea to make sure you have it correct. See, number 2, we've got 6x to the 4th minus 9x squared. Okay, with the numbers 6 and 9, the largest number that divides evenly into both 6 and 9 is 3. And for the variables, I've got x to the 4th versus x squared. So remember, you always take out the one with the smallest exponent. So the 3x squared is what they have in common. Okay, if you divide the first term by 3x squared, you'll be left with 2x squared. When you divide the second term, the minus 9x squared, by 3x squared, you're left with minus 3. So I've got 3x squared times 2x squared minus 3. That's our final answer. And again, notice, if you distribute the 3x squared, you will in fact get the original problem. Number 3. Excuse me, I've got 5x cubed y to the 7th minus 10x squared y to the 4th plus 15x to the 7th y. Okay, so again, we look at the numbers, 5, 10, and 15, and we look for the largest number that will divide evenly into all three. It's going to be 5. For the variables, okay, looking at the x, everybody has an x. I've got a cubed, a squared, and a 7th. So the smallest exponent is going to be the squared. For the y, I have exponent of 7, 4, and 1. So the smallest exponent is going to be 1. So I can factor out 5x squared y. That will go outside the parentheses. So 5 is what the numbers have in common. X squared is what the x's have in common. And y is what the y terms have in common. Now to figure out what's left, again divide each one of these three terms by 5x squared y. Okay, when I divide 5 by 5, I get 1, so we're not going to write it. X cubed divided by x squared is just x, and y to the 7th divided by y is x, y to the 6th. Now the next one, I'm going to have a minus sign, of course. 10 divided by 5 will be 2. X cubed divided by x squared, x squared divided by x squared will be 1. So far I still just have 5. And y to the 4th divided by y will be y cubed. Notice we're subtracting exponents. The second law of exponents. We're dividing, subtract the exponents of like base. So I have minus 2y to the 5th. Oh, excuse me, 2y cubed. My mistake. 4 minus 1 does give me 3. Okay, for the last term, 15 divided by 5 is 3. X to the 7th divided by x squared is x to the 5th. And y divided by y is 1, so I don't have a y term. So I'm going to have 3x to the 5th. And that's our complete factorization. That's our final answer. Number 4. I've got 5x times 2a minus 5 plus 3 times 2a minus 5. Okay, I've got the 2a minus 5 in parentheses, and that's what they both have in common, 2a minus 5. So I'll put the 2a minus 5 in front. So again, 2a minus 5 in common. I've underlined it to emphasize it. Okay, when I factor out 2a minus 5, so dividing this first term by 2a minus 5, I'm left with 5x. Dividing this second term by 2a minus 5, I'm left with the 3. So I'll be left with 5x from the first term plus 3 from the second term. Okay? And that's our final answer. Now again, in the problem, resist the temptation to distribute the 5x and the 3. Remember, you're doing the opposite of multiplying. You're trying to factor something out. Number 5. I've got 3x squared times 3y plus 10 minus 7 times 3y plus 10. Okay, we just have two terms. These two terms have 3y plus 10 in common. So I'll be factoring out 3y plus 10. If I factor 3y plus 10 from the first term, I'm left with 3x squared. When I factor from the second term, again dividing 3y plus 10, I'm left with minus 7. And there's your complete factorization. There's your answer. Now, when you're doing factoring, factoring out the greatest common factor should be your first attempt in factoring. So all the other factoring techniques assume that we have already factored out the greatest common expression. Okay? They assume that you've done that. If you haven't done it, the other techniques can actually still apply, just that you postpone when you have to do it. When factoring, your first attempt should always be to factor out the greatest common expression. That should be the first thing you try. Let's look at our second factoring technique. Factoring by grouping. Okay, factoring by grouping is always done when there are an even number of terms. It's really an even number of terms greater than 2. If you just have 2 terms, the grouping is already done for you. So we always assume from now on that you have already factored out any common expressions. It makes the work a little bit easier. If you have not factored out all common expressions at the beginning, you will need to do so in the end. Because remember, factoring always means factor completely. So let's look at 4 terms. Okay, because again, when there's 2 terms, the grouping is already done. So 4 terms. The first thing that we try is grouping the first 2 terms and the last 2 terms. So that will take you from 4 terms down to 2. So step 1, factor out anything in common. Again, that should always be your first step whenever you're factoring, is to factor out all common expressions. Step 2, group the first 2 terms and group the last 2 terms. This is usually done by just inserting some parentheses. Number 3, step 3, factor out a common expression from the first 2 terms and factor out a common expression from the last 2 terms. So we're treating it as though it's actually 2 separate problems after we do the grouping. Now this would be one of the few times when if we can factor out 1, we would actually write down 1. Step 4, you should now have 2 terms with a common factor. Factor it out. So at the end of step 3, when you're getting ready to do step 4, it should look like the last 2 examples we did for the grouping, for the factoring out the greatest common expression. Note, if you do not have 2 terms with a common factor, then the polynomial either does not factor this way, in which case you must try another method, or you may have to rearrange the original terms. Very seldom do you have to rearrange the original terms. Most of the time it is already written in the correct order. Factor completely. Our first one, I've got x cubed plus x squared plus x plus 1. Again, you first check to see, do they have anything in common other than 1? Turns out they don't. So I'm going to group the first 2, group the last 2. So here are the first 2 terms, Here are the last two terms. Now again, notice if you do drop parentheses, we're back to where we began. Okay, looking at the first two terms. The first two terms have x squared in common. Again, remember, take out the smallest exponent. The last two terms just have 1 in common. They have actually written it. Okay, now notice I have x plus 1 and x plus 1 common to both terms. Again, we went from 4 terms to 2 terms. This plus sign outside parentheses is what's separating the terms. So when I factor out x plus 1, I'm left with x squared plus 1. And again, if you FOIL that out and write it in correct order, you will get the original problem. So all of the factoring that group first two terms, the last two terms, will follow this pattern. Notice we were able to do it in 3 steps. Now the only time there would be a 4th step is if in the beginning all 4 terms had something in common. Our second example. We've got 6x cubed minus 3x squared minus 2x plus 1. Okay, we're going to group the first two, we're going to group the last two. Now because of this minus sign in front of the 2x, I don't just put parentheses. So I'm going to group the first two, group the last two. So the first two I will just put parentheses around 6x cubed minus 3x squared. Now if I just do parentheses around the 2x plus 1, that'll be wrong. This minus sign is going to make me put a minus sign outside the parentheses when I do my factoring. So first two, last two. Now notice this minus sign is still with the minus 2x. Right? So I've got 6x cubed minus 3x squared plus negative 2x plus 1. Okay? Now I'm getting ready to take care of this minus sign. Okay, from the first two, they have the number 3 in common, they have x squared in common. Now, for the next two, because of this minus sign, that minus sign right there, I'm going to factor out at least negative 1. So it doesn't matter whether this one has a minus sign or not. It's the fact that this one does that makes me factor out minus 1. And it does turn out that's all I can factor out is minus 1. So 3x squared from the first two, minus 1 from the last two. When I factor out minus 1, that'll become 2x minus 1. Factoring out the minus 1 changes the signs. So factor 3x squared from the first two, negative 1 from the last two. Now again, if this term is minus, regardless of the sign of that one, if that term is negative, that makes me factor out a negative, and then I look for anything else I can factor. Now they have 2x minus 1 in common. That is what I can factor out from the grouping. So if I factor out 2x minus 1, I'll be left with 3x squared minus 1. Notice, after you get this expression in parentheses they have in common, the next factor is just whatever's not in parentheses. So 2x minus 1 times 3x squared minus 1. Again, the order in which you write the factors doesn't matter. If you'd written 3x squared minus 1 times 2x minus 1, it'd be the same thing. The order of the factors does not matter. But again, we usually like to put numbers first, then monomials, then binomials, then trinomials, and so forth. So the factors are arranged in order of their size, starting with numbers, monomials, binomials, trinomials, etc. Number 3, I have 4ax plus 3a minus 12x minus 9. You look for anything they have in common. They have nothing in common. So I've grouped the first two, I've grouped the last two. Notice I put plus negative 12x minus 9. Okay, now looking at the first two, what do they have in common? Okay, no number, but they have the letter a in common. So from the first two, I can factor out a. Looking at the last two, now again, because this is a minus, I'll certainly take out a minus. See, 12 and 9, they have 3 in common. Now there is no letter. So from the first two, take out a, that'll leave me 4x plus 3. From the last two, take out minus 3, that'll leave me 4x plus 3. They now have 4x plus 3 in common. So I factor out 4x plus 3, I'll be left with a minus 3. And let's take a look at one more. Again, notice it is following the same pattern that the other two have followed. I've got 3x squared minus 6x minus 2x plus 4. Okay, now I know I can combine these two terms, but don't do it. There's a reason why we've done this. We're setting you up for some factoring technique that comes later. So don't combine those terms. Factor by grouping. So I'm going to group the first two, group the last two. So when I group the first two, I'll have 3x squared minus 6x. When I group the last two, I'll have plus negative 2x plus 4. Okay? I've grouped them. Now, from the first two, the number they have in common, the largest number divides evenly to both 3 and 6 is 3. And I'll take out an x. I'll take out 3x, leaving me x minus 2. From the last two, again, because of this minus sign, I'll take out a minus. Then 2 and 4 have the number 2 in common. So I'll take out minus 2, leaving me x minus 2. They now have x minus 2 in common. So I factor out x minus 2, and I'll be left with 3x minus 2. Now again, you could write the 3x minus 2 first and have 3x minus 2 times x minus 2. That's fine. If the factors are the same size, like they're both binomials, the order doesn't matter. Okay, a times b is b times a. Commutative property, right? But remember, other than that, you write numbers first, monomials second, then binomials, then the trinomials. We'll have a factoring technique that does give us trinomials. Okay, now that was when you have 4 terms. Okay, the next even number after 4 would be 6, but we do have another technique for factoring 4 terms. So, number 2 of the factoring with 4 terms. Group the first 3 and group the last 1. Okay, that would still go from 4 terms down to 2. You group the first 3 and the last 1. This technique will be done later after we've learned some more about factoring, okay, because this is only our second factoring technique, so we don't quite have enough tools yet to do the grouping of first 3, last 1. So let's move on to the next even number. 6 terms. Okay, now we do not do 6 terms or higher as a grouping problem in this course. That means we do some other factoring techniques, such as factoring out a common expression. If there are 6 or more terms, it's actually a problem of factoring out a common expression. Now, after we factor out a common expression, 6 terms in general requires the same tools in order to factor the grouping of first 3 and last 1. So for us, we don't do the grouping with 6 terms. Our third factoring technique, factoring trinomials of the form x squared plus bx plus c. This is the usual classical factoring. This is just FOIL in reverse. This was the real reason for becoming good at FOIL, so we could factor trinomials easily. It's also the reason you want to write the result of a FOIL problem in order. You want to write it in the order of first, outer, inner, last. It makes it easier to see how to factor it. We start with x squared plus bx plus c. Okay, so that's the problem that's given to us. We then write it as x plus something times x plus something. Now notice, if you're doing FOIL, x times x will give you x squared. Kind of a trivial observation. These are exponents of 1. That was the exponent of 2. We divided the exponent by 2 in the factoring. So notice, this has to be an even exponent. So if this were x to the 4th, you'd have x squared and x squared. So for the x cubed, notice I can't do this. It means I have to try something else. So you have to start off with an even exponent. Now, the question marks numbers that satisfy the following. So here comes the fun part. How do you figure out the numbers? Number 1, their product, including signs, equals the constant term of the original trinomial. Okay, the constant term, if you write it in order, is the last term. So their product is the last term. Number 2, their sum, including signs, equals the coefficient of the middle term of the original trinomial. So that's the b. So multiply to be the constant term, add up to be the coefficient of the middle term. Okay, now we have some hints and suggestions for finding the question marks when you're doing the x squared plus bx plus c equals x plus something and x plus something else. It has to do with the signs. So number 1, if the constant term of the original trinomial is positive, so that means you really see plus a number here, then both question marks have the same sign. It's like both positive or both negative, and that sign is the middle term of the original trinomial. So if this is a plus, they both have the sign of the middle. What if it's not a plus? Number 2, if the constant term of the original trinomial is negative, so you see minus a number, like minus 12, then the question marks will have opposite signs, so one positive, one negative, and the bigger one will have the sign of the middle term of the original trinomial. So if this is a minus, opposite signs, bigger has the sign of the middle. Okay? So those are your kind of hints and suggestions. Those always work, by the way. There are a few other hints and suggestions that don't always work. They just work some of the time, so we won't worry about those. Now all this is assuming that we have factored out all common expressions and the trinomial is written in correct order. So that should be the first thing you try. And not writing it in correct order is going to be something where you're going to really hate the people that don't do FOIL the correct way. Remember, FOIL is first, outer, inner, last, not first, last, outer, inner. So some examples. Factor completely. Okay, first one. I've got x to the fourth minus 4x minus 21. Okay, if we run through our little hints and suggestions, we need numbers whose product is negative 21, okay, and whose sum is negative 4. Since the constant term is negative, right, minus 21, the numbers will have opposite signs. The middle term is negative, so the large number will be negative. So we make a list of the factors of negative 21 that satisfy these properties and look at their sums in order to find the correct pairs of factors. Excuse me, the correct pair of factors. Okay, some of you back in high school may have been told you have to show this work. If you can actually see the numbers at work, don't go through this agony. Just write down your factoring. So the factors and the sum of the factors. Okay, negative 21 can be negative 21 times 1. Okay, the sum, negative 21 plus 1, is negative 20. That's not going to work. I want a negative 4. Okay, I can also write negative 21 as 7 times 3. Now again, remember the larger number has the minus. So minus 7 times 3, when I add it up, I get negative 4. That's the one I want. So I'm going to have the numbers minus 7 and 3 in my factorization. So I'll have x minus 7, x plus 3, or you can reverse it. So x squared minus 4x minus 21 is x minus 4 times x plus 3. Or again, if you want to write it as x plus 3 times x minus 7, that's fine. Notice you can check this using FOIL to see if it's the original problem. Now, when you make your list, if you never do find the factors that add up to be the middle, either you've skipped them, lost them, or else it really doesn't factor. Number 2, I've got x squared plus xy minus 12y squared. Okay, it is written in correct order. The powers of x are going down, the powers of y are going up. They do have nothing in common. So we need numbers whose product is negative 12 and whose sum is 1. Remember, if you don't see the coefficient, it's 1. Since the constant term is negative, so I've got a minus 12, numbers have opposite signs, and since the middle is positive, right, I've got a plus here, the bigger number will be positive. So if you see the numbers, again, don't go through this, but if we make our little list, okay, 12 can be 12 times negative 1, okay, and the sum is 11. I can also divide 12 by 2, so I can have 12 times negative, 6 times negative 2. The sum is 4. Okay, we're getting closer. I can also divide it by 3. So 4 times negative 3, when I add it up, I get 1. So I'm going to be using 4 and negative 3. Okay, for the x and the y, I'm going to have x plus 4, y times x minus 3y. Again, of course, you could switch the factors. X minus 3y, x plus 4y. The important part is that the 4 gets the plus, the 3 gets the minus. And again, you can check doing FOIL. Number 3, I've got x cubed plus 6x squared plus 8x. Okay, you look for something they have in common. All of them have an x term. Okay, they have no number in common besides 1. The smallest power of x is x. So first factor out an x. I'll be left with x squared plus 6x plus 8. Now, it could be that's all there is to do. I'll look inside the parentheses here. I want numbers that multiply to be 8 and add up to be 6. Since this is a positive and this is a positive, I'm looking at all positive numbers. So the factors of 8 and look at the sum. Okay, 8 can be 8 times 1. The sum is 9. That's no good. I want 6. It could also be 4 times 2, and that adds up to be 6. Okay, so I'll be using x plus 4 and x plus 2. Again, don't lose this factor of x you factored out. Now, because it is a monomial, it comes first. So I'm going to have x times x plus 4 times x plus 2. Now, you could switch the x plus 2 and the x plus 4, but please put the monomial first. Remember, the order of the factors is numbers, monomials, then binomials. Number 4, I've got x to the fourth minus 12x squared plus 35. Okay, because of the x to the fourth, I'm going to have x squared and x squared. Remember, divide the exponent by 2. This is in correct order. They have no numbers in common. So I'm going to start with x squared and x squared now. With the 35, multiply to be 35, add up to be minus 12. Okay, because that's a positive, both terms will be positive or both terms will be negative. Because the middle term is negative, they're both going to be negative. Okay, so I want two negative numbers that will multiply to be 35 and add up to be negative 12. So I start with negative 35 times negative 1. They add up to be negative 36. That's no good. It ends in a 5. I can divide by 5. Negative 7 times negative 5. They add up to be negative 12. That's what I want. So I'm going to have x squared minus 7, x squared minus 5. That's our complete factorization. Okay, our next factoring technique is going to look at what happens if that leading coefficient is something other than 1. So factoring trinomials of the form ax squared plus bx plus c with a not equal to 1. Okay, we just finished the case where a was 1. There are actually a couple ways you can do this, and I'm basing this upon what students in the past have always said that they preferred. Even if they didn't understand it, they did prefer it, which I always thought was kind of odd. So we'll use a method called splitting the middle term, or the AC method. The AC as in this A and this C. The idea is to turn the trinomial into a polynomial with 4 terms and then factor by grouping. Because grouping is so nice to do, we want to turn it into that type of problem. Now, if you actually do see how to factor it without going through all this, don't go through all this. Just write down the factoring. Remember, your goal is actually to factor. So this is kind of your method of last resort because you don't see how to factor it. So in the case where a is equal to 1, splitting the middle term becomes what we were doing in part 3. What we just finished is the case when a is equal to 1 of splitting the middle term. Hopefully you will see that when we write out the method for how do you split the middle term. So steps for splitting the middle term. Okay, we start with the trinomial ax squared plus bx plus c. So you're going to make sure it's written in correct order. Okay, step 1 is not too bad. Step 1, find the product a times c. Now be aware, this could be an incredibly large number, even if a and c are relatively small. But finding the product AC is not too difficult. Now don't lose signs. Step 2, here's where the work begins. Find numbers whose product, including signs, is the number a times c, and whose sum, including signs, is the coefficient of the middle term of the original trinomial. Notice this is what we were doing back in part 3, and in part 3 a times c would just be c. Okay, now the rules about signs still kind of applies here. Step 3, using the numbers from step 2, write the original trinomial as a polynomial with 4 terms. Okay, step 3 is the splitting the middle term step. So step 3 is where you actually split the middle term as the sum or difference of 2 other terms. Step 4, factor by grouping. Now it turns out if this is not going to work, if the polynomial does not factor, it falls apart in step 2. You never do find the numbers to split the middle term. So if you can't split the middle term, that's how you know it won't factor. Again, a very simple problem where you can't factor is x squared plus x plus 1. It doesn't factor. Let's factor completely. Okay, our first one. I've got 6x squared plus x minus 12. Now again, if you see how to factor it, just go straight to the factorization. But we're going to run through the steps of splitting the middle term. Okay, first, do they have anything in common? No. Is it written in correct order? Yes. So, step 1, find a times c. That's going to be 6 times negative 12. I get negative 72. So remember, 6 times negative 12. Okay, here comes the fun part. I want to find numbers whose product is negative 72 and whose sum is 1. Okay, since a times c is negative, numbers will have opposite signs, one positive, one negative, and the bigger one will have the sign of the middle term. Okay, so again, we make our list. So I want one positive, one negative, and the large one will be positive. So negative 1 times 72 adds up to be 71. That's no good. I have negative 2 times 36. That adds up to be 34. That's no good, but I am getting smaller. Negative 3 times 24. Sum is 21. Now again, remember this always has to multiply to be negative 72. Negative 4 times 17. That gives me negative 72, but the sum is only 14. Negative 6 times 12. I'm getting closer. Negative 8 times 9. Yay, that worked. It added up to be 1. So I'm going to be using negative 8x plus 9x. Now the order in which you write them doesn't matter, but students usually like to put the positives together and the negatives together. But again, we'll be using negative 8 and 9 to split the middle term. So using negative 8 and 9, we write the original trinomial as a polynomial with 4 terms. So we're splitting the middle term. So the 6x cubed plus x minus 12 becomes 6x squared. from 6x squared plus 9x minus 8x minus 12. So there's my 9 and negative 8 that I got from step 2. And notice this adds up to be x. Okay. Now we group. Now 6x squared plus 9x plus negative 8x minus 12. So I'm going to factor by grouping. I group the first two, group the last two. Okay, from the first two, we can factor out 3 from the numbers and x. So I factor out 3x. From the last two, I can factor out a minus, and with 8 and 12, I can do 4. So 3x from the first two gives me 2x plus 3, minus 4 from the last two leaves me with 2x plus 3. They now have 2x plus 3 in common. So I have 2x plus 3 times 3x minus 4. Or you could have written 3x minus 4 times 2x plus 3. Now again, if you had seen this factorization to start with, you don't need to go through all this. Splitting the middle term, I admit, is long, but it does work. And it will let you know whether or not the polynomial will in fact factor. Let's take a look at another one. I've got 6x squared plus 17xy plus 7y squared. Again, you check to see anything in common. No. Is it written in correct order? Yes. The powers of x go down, the powers of y go up. So let's try to split the middle term. So step 1, a times c. 6 times 7 gives me 42. Okay, I want numbers whose product is 42 and whose sum is 17. Since this is a positive and that's a positive, everybody will be positive. So 42, I could write it as 42 times 1. The sum is 43. That's no good. Okay, 42 is even. I could do 2 times 21. The sum is 23. Ooh, I'm getting a lot closer. Can 42 divided by 3? 3 times 14? Yes. The sum is 17. So that's what we're going to use to split the middle term. 3 and 14. Now notice, since they're both positive, there's nothing we can do about a group the positive, group the negative. But again, it doesn't matter when you split the middle term. So step 3, when you use 3 and 14 to rewrite the trinomial as a 4-term polynomial. Remember, a 4-term polynomial is actually called a quadrinomial. So 6x squared plus 3xy plus 14xy plus 7y squared. I've split the middle term. Again, notice these two add up to be the 17. Okay, I'm now getting ready to factor by grouping. So this is where we left off from the previous slide. So I'm going to group the first two, group the last two. So 6x squared plus 3xy plus 14xy plus 7y squared. From the first two, the number I can take out that 6 and 3 have in common is 3. They also have x, so factor out 3x from the first two. The last two, the number that divides evenly into 14 and 7 will be 7, and I can take out a y. So take out 3x from the first two, 7y from the last two. If I factor out 3x from the first two, I'm left with 2x plus y. If I factor out 7y from the last two, I'm left with 2x plus y. They now have 2x plus y in common. So I have 2x plus y times 3x plus 7y. Or you could write 3x plus 7y times 2x plus y. Now, because students have done it in the past, please don't suddenly write it with y first. It's alphabetical order. So the factorization is 2x plus y times 3x plus 7y. Let's try one more. I've got 10x to the fourth plus 29x squared y minus 21y squared. Check to see, do they have anything in common? No. Is it in correct order? Yes, the powers of x are going down, the powers of y are going up. Okay, so I factor by splitting the middle term. A times c, 10 times negative 21, I get negative 210. We need numbers that multiply to be negative 210 and add up to be 29. Okay, so this is negative, opposite signs. Their sum has to be positive, the larger has a plus. So let's make our little list. Negative 1 times 210. Okay, the sum is actually 209, not 219. That should be 209. Okay, I've skipped a whole bunch. I didn't know 5, so I tried dividing by 5. Negative 5 times 42, I get 37. I'm a lot closer. Let's see. 6 can go into 210. So negative 6 times 35, it adds up to be 29. Now again, that should be 209 right there, not 219. So I'll use negative 6 times 35 to split the middle term. Now again, I can't put positives together and negatives together. But again, the order really doesn't matter. So step 3, using the numbers negative 6 and 35, I'm going to split the middle term. So I've got 10x to the 4th plus 35x squared y minus 6x squared y minus 21y squared. Okay, so there I have split the middle term. Now we're going to get ready to factor by grouping. Group the first two, group the last two. Okay, this step will be on the next slide. Okay, so factor by grouping. So I'll group the first two, and then I'll put plus negative 6x squared y plus, minus 21y squared. So group the first two, group the last two. Okay, from the first two, with 10 and 35, I can divide both of them by 5, and they have x in common. The smallest power is exponent. Smallest power is 2, so I'll take out 5x squared from the first two. That'll leave me 2x squared plus 7y. Okay, from the last two, I can take out a minus. With 6 and 21, the largest that divides evenly to both 6 and 21 will be 3. And no x in common, but they do have a y. So from the last two, I'll take out minus 3y, leaving us 2x squared plus 7y. They now have 2x squared plus 7y in common. When I factor that out, I'll be left with 5x squared minus 3y. So that's our complete factorization. Let's go on to our next factoring technique. Perfect trinomial squares. Now notice it is a trinomial. Our last two factoring techniques have focused on trinomials, so this is just another way of factoring trinomials. It actually is not a new way. We're going to make use of what we've already seen. It has to do with how do we write our answer. So definition, a perfect trinomial square is a trinomial that factors as the square of a binomial, like 5 plus xy squared or something like that. So factor completely. I've got x squared plus 12x plus 36. You notice it is a trinomial. I want numbers that multiply to be 36 and add up to be 12. So if I make my list, 1 times 36 adds up to be 37. I can do 2 times 18 adds up to be 20. 3 times 12. No, I didn't do 3 times 12. I did 4 times 9. I got 13. Ooh, I'm even closer though. And 6 will go into 36, so 6 times 6, that adds up to 12. So it's going to be x plus 6, x plus 6. It's okay if you leave it like this, but the wise algebra student will write x plus 6 squared. This is preferred. Okay, this is actually preferred. This is not wrong. I don't mark it wrong because it's not wrong, but this is what's preferred. You need to get used to writing it like this, though. Okay, just like you wouldn't write xx, you'd write x squared. You should do the same thing with a binomial. Now I've got x to the 4th minus 10x squared y plus 25y squared. Okay, anything in common? No. Is it in correct order? Yes. The powers of x go down, the powers of y go up. Okay, we need numbers whose product is 25 and whose sum is negative 10. It's negative 5 and negative 5. So I'll have x squared minus 5y times x squared minus 5y, better known as x squared minus 5y squared. Now, kind of the quick and dirty way to do this. So the quick way to factor a perfect trinomial square. Now, it depends upon you recognizing that you have a perfect trinomial square. In order to have a perfect trinomial square, let me go back. In order to have a perfect trinomial square, the first term has to be a perfect square, including the coefficient, and the last term has to be a perfect square, including the coefficient. So, step 1, take the square root of the first term. For variables, that means divide the exponent by 2. Step 2, keep the sign of the middle term. If it's a plus, you write a plus. If it's a minus, you write a minus. And step 3, take the square root of the last term. Now again, for variables, that means divide the exponents by 2. For the numbers, you simply have to recognize the perfect square. Like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. So you should then verify with FOIL, or by squaring out your answer, that you did indeed have a perfect trinomial square. Let's try some that way. So back to the examples. This would be example number 3. So I've got 16x squared minus 24x plus 9. Okay, they do have nothing in common. It is in correct order. Okay, 16 is a perfect square. 9 is a perfect square. 16 is 4 squared, 9 is 3 squared. So if I do the factoring like I'm supposed to, okay, 4x minus 3 being squared. So 4x is the square root of 16x squared, the sign of the middle term, and 3 is the square root of 9. And if you do a quick FOIL on that, you do in fact get the original problem. Again, this all depends upon that you recognize in the beginning that you did in fact have a perfect trinomial square. Let's try one more. I've got 49x squared plus 126xy plus 81y squared. Okay, 49 is a perfect square, 7 times 7. 81 is a perfect square, 9 times 9. Now notice, if you were to do a times c, 49 times 81 would be huge. So I'd do the square root of 49x squared, the sign in the middle, which would be plus, and the square root of 81y squared. So 7x is the square root of 49x squared, sign of the middle term, and 9y is the square root of 81y squared. And if you do a quick FOIL on that, you will get the correct answer. So remember, this is our complete factorization. Okay, let's go to our next factoring technique. Factoring differences of squares. Notice it is a difference, not a sum. So part A, the actual difference of squares. Okay, recall that a plus b times a minus b was equal to a squared minus b squared, and a squared minus b squared was called a difference of squares. So we're starting with this as our problem. The exponents are even. We're ending up with this as factors. So the difference of squares is going to factor as conjugates. Okay, notice these exponents are 1. I divide those by 2. So difference of squares, divide the exponents by 2, and then write conjugates, 1 plus, 1 minus. It doesn't matter which one you write first. Remember, the order doesn't matter. Notice that the exponents on the right-hand side of the equal sign are half of the exponents on the left-hand side. Okay, again, they're 1s, and those were 2s. So if these were 4s, these would be 2s. Now, difference of squares sometimes will just factor all day long. You'll have a difference of squares, you'll factor, you'll have another difference of squares. Because remember, when you do the conjugates, 1 does have a minus. So warning, a sum of squares will not factor. X squared plus y squared, it does not factor. And in terms of an answer, that's what you write. Does not factor or will not factor. Don't leave it blank. It looks like you skipped the problem. Now, clues that you have a difference of squares. You know that you should be factoring as conjugates. Okay, number 1, you have 2 terms separated by a minus sign. Okay, that's kind of your first clue, because remember, you want a difference. Okay, number 2, even exponents on the variables. Because remember, you're dividing the exponents by 2, so you have to have even exponents on the variables. Okay, it is up to you to recognize the coefficients are perfect squares. Again, if you have to run through them in your mind, you know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. Let's try some examples. Factor completely. Again, remember, always factor completely. Okay, our first one, I have x squared minus 9. Okay, I do have an even exponent. I have a minus sign, and 9 is 3 squared. Okay, so you have to observe that 9 is 3 squared. So factors as conjugates, x plus 3, x minus 3. Or, like I have here, x minus 3, x plus 3. Remember, the order of the factors does not matter. Number 2, I have x to the 4th minus y to the 8th. Okay, the coefficients are 1, and 1 is a perfect square. Those are, in fact, even exponents. I do have a minus sign. Divide the exponents by 2. So I'll have x squared plus y to the 4th times x squared minus y to the 4th. Even exponents still. Divide them by 2. Now remember, sum of squares will not factor, but don't lose that factor. So I'll have x squared plus y to the 4th times x plus y squared, x minus y squared. So again, this factor is still a difference of squares. If you stop here, it's not correct. Ideally, we would like to have the variables inside the parentheses have exponents of 1. Typically, if you can get down to at least one variable with an exponent of 1, chances are you're done. Number 3. 16x to the fourth minus 9y squared. Okay, I do have even exponents. I have the minus sign. 16 is a perfect square. 9 is a perfect square. So dividing the exponents by 2. 4x squared plus 3y, 4x squared minus 3y. Now again, I do have a variable with exponent of 1 inside the parentheses, so chances are it's not going any further. Number 4, I've got x squared plus y to the 6th. Okay, I have coefficients of 1, 1's a perfect square. I do have even exponents, but I don't have a minus. This does not factor. So remember, sum of squares will not factor. So it doesn't have to look weird to not factor. Number 5, I have x squared minus 8. I do have an even exponent. I have a minus sign, but 8 is not a perfect square. Remember, 1 squared is 1, 2 squared is 4, 3 squared is 9. I just passed 8. We don't use irrational numbers, so it will not factor. 8 is not a perfect square. Again, we do not factor using irrational numbers. We very seldom want to factor using fractions. We'd like to keep it with integers. Number 6, I have 3x squared minus 48. Let's see, 48 can be divided by 3. So first let's factor out the 3. So divide 48 by 3, so put the 3 in front, and I'm left with x squared minus 16. 16 is a perfect square. I do have a minus. So don't lose the 3, it goes in front. So 3 times x plus 4, x minus 4. Okay, remember the order is numbers, monomials, binomials, and then trinomials. Let's go to our next factoring technique. Grouping of first 3 and last 1. Now this is still under the category of factoring difference of squares. So evidently the grouping of first 3 and last 1 is supposed to lead to a difference of squares. Okay, clues for the grouping of first 3 and last 1. First clue, the last term has minus sign in front of it. Second clue, the last term is a perfect square, which for variables means you have an even exponent. Now, kind of the dead giveaway clue. The last term seems to have nothing to do with the first 3 terms. Okay, that's usually the dead giveaway, that you're grouping first 3, last 1. Now, when you do have 4 terms and you have no idea which grouping should it be, first 3, last 1, or first 2, last 2, always start with first 2, last 2. But again, look for clue number 3, that the last term seems to have nothing to do with the first 3. The grouping of first 3 and last 1 will always lead to a difference of squares. Always. Now, the grouping of first 2, last 2 kind of had the same 3 steps, and there will only be a 4th step if they have something in common. The same thing goes on here. They will follow the same pattern. So, some examples. Let's factor completely. So I've got this rather weird looking polynomial, x squared plus 6x plus 9 minus 4y to the 4th. It's kind of like, why all of a sudden is there a y term sitting here? So we're going to group the first 3 and the last 1. Notice grouping first 3 and last 1 just means put parentheses around the first 3. Okay, now x squared plus 6x plus 9, classic trinomial. I want factors that multiply to be 9 and add up to be 6. It's 3 and 3. So I've got x plus 3 squared minus 4y to the 4th. Now don't leave it like this. It's not factored completely. If you have a plus or a minus sign sitting outside parentheses, you're not done factoring. This is an a squared minus a b squared. The a is the x plus 3. The b is 2y squared. So it's going to factor as conjugates. X plus 3 minus 2y squared, x plus 3 plus 2y squared. And that's as far as it'll go. You can verify that this is the correct factorization by multiplying this out and seeing if it's the original problem. Most of the time we don't want to do that. So again, this is the a, x plus 3, 2y squared is the b. You divided the exponents by 2. You took the square root of 4. Number 2, I've got x to the 4th minus 12x squared plus 36 minus 49p squared. It's almost like, where did 49p squared come from? It's got a minus sign in front of it. This is a perfect square. 49 is 7 squared. Group the first 3, group the last 1. Okay, for the the first three even exponent. So let's see, is it a perfect trinomial square? I can take the square root of that. Square root of 36 is 6. So it should be x squared minus 6 quantity squared. Okay, now divide the exponent outside parentheses by 2, and the square root of 49 is 7. So I should have x squared minus 6 minus 7p, x squared minus 6 plus 7p. Okay, don't put parentheses inside the parentheses in your factoring. And again, this step we know is not completely factored. In fact, it's not factored at all because this minus sign outside parentheses. Similarly right here, if you have a plus or a minus sign outside parentheses, it's not completely factored with one exception. You are allowed to have a minus sign in front of everybody. Notice we have very seldom had that. Notice they both followed the exact same pattern. Okay, now we could factor difference of squares, but we could not factor a sum. With cubes, we can do both. For factoring sums and differences of cubes, it comes down to a formula. So the sum of cubes, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Notice the other factors are trinomial. The difference of cubes, a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Notice they look very similar. The only difference is the sign. Notice for the first one with a plus, the first factor has that, and the second factor in the middle is opposite. For the one with a minus, the first factor has a minus, the middle term of the second factor is opposite. The trinomial in general won't factor, so don't worry about trying to factor the trinomial. So again, those are your formulas. Notice the first factor, you divided these exponents by 3. You took the cube root. So to do the cubes, you have to have multiples of 3 on the exponents. So notice that the two formulas look very much alike. The only differences are the signs in the middle of each expression, right? Plus, plus, minus, 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 plus. The first factor always makes sense to people. You just divide the original exponents by 3. You're really doing a cube root. Again, the numbers you have to recognize perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on. Obtaining the second factor from the first factor, because we always say that the second factor comes from the first factor. So we always say the second factor comes from the first factor. The second factor is obtained from the first factor in the following way. So this is how you get the second factor from the first factor. Step 1, square the first term of the first factor. Whatever it is, just square it. Step 2, take minus the product of the two terms in the first factor. The take minus part means change the sign. The sign in the middle of the first factor is always the same as the sign in the middle of the problem. The sign of the middle term of the second factor is always the opposite of the sign in the middle of the problem. And step 3, square the last term of the first factor. So in the second factor, the first term and the last term are always plus. The middle term has the opposite sign of the original problem. The first factor always has the same sign as the problem. Now, how do you know if you have a cube? So again, typically the second factor will not factor any further. Okay, it typically won't, so don't strain your brain trying to figure it out. So clues, you have a sum or difference of cubes. Again, it's a sum or a difference, so we can't just go by a minus sign. First clue, you have two terms. Okay, now remember you want cubes, so the exponents and variables are multiples of 3. They do not have to be the same multiple of 3. It is up to you to recognize whether or not the coefficients are perfect cubes. And again, remember, just cube the numbers if you have to. 1 cubed is 1, 2 cubed is 8, 2 times 2 times 2. 3 cubed is 27, 4 cubed is 64, and so forth. Now, you do have to have variables. If you don't have any variables, you don't really have a factoring problem. You've actually got a my dear Aunt Sally problem. Okay, with this, we have basically got all of our factoring techniques, okay, that we're going to look at in this course. So I can now, in my examples, give you almost anything I want. So that being said, let's factor completely. Okay, my first one is x cubed plus 27. Okay, I do have two terms. I've got an exponent that's a multiple of 3, and 27 is 3 cubed. So, again, the first factor, take cube roots. Divide that by 3, cube root of 27 is 3. This factor comes from the first one. Square the first term. Take minus the product. That's a plus, put a minus. 3 times x, and square the last. Please, don't write 3 squared. 3 squared is 9. The downside of using the formula is, it's kind of like, what happened? You just have to know the formula. Again, remember, the second factor comes from doing these things to the first factor. And the first factor are just cube roots, which means divide exponents by 3. For the numbers, you simply have to maybe count on your fingers to figure out what they are. Number 2, I have x cubed minus 125y to the 6th. Okay, that is a minus sign. It could be a difference of squares, but nope, multiples of 3. Now, is 125 a perfect cube? See, 5 times 5 times 5, yes. So the first factor, take cube roots. The first factor will be x minus 5y squared. Remember, cube roots means divide the exponents by 3, and for 125, its cube root is 5. The second factor comes from the first one. Square the first term. Change the sign. Do the product. 5xy squared, square the last. Don't forget to square the 5. Remember, in the first factor, the sign matches the problem. In the second factor, it's opposite from the problem. And again, if you're really bored, you could verify that does in fact work by multiplying this out and seeing if it's the original problem. Notice a lot of terms have to add up to be 0. Number 3, I have x to the 6th plus y to the 9th. Okay, I do have only two terms. It can't be a sum of squares, that won't factor. Are these multiples of 3? Yes. Remember, the first factor, divide the exponents by 3. Of x squared plus y to the 3rd. This factor, remember, comes from the first one. Square the first term. X squared squared is x to the 4th. Change the sign. That's a plus, which matches the problem, so it has to be a minus. Do the product. X squared, y cubed. Then square the last. Y cubed squared. That's going to be y to the 6th. Remember, a power to a power, multiply the exponents. And again, you can always check by multiplying it out. And again, remember, this factor came from the first one. Square the first term. X squared squared is x to the 4th. Change the sign. Do the product. X squared, y cubed, and then square the last. Y cubed squared is y to the 6th. Please don't change the order of the letters. Someone always does that, and I don't know why. Number 4, I have 8x cubed minus 27y to the 6th. Let's see. Multiples of 3 for the exponents. Are 8 and 27 perfect cubes? Let's see, 8 is 2 cubed, 27 is 3 cubed. So the first factor, remember, do cube roots. So I'm going to have 2x minus 3y squared. Second factor, coming from the first one. Square the first term. Don't forget to square the 2, 4x squared. Change the sign. Do the product. Okay, 2 times 3 is 6. So I get 6xy squared. Please don't leave 2 times 3. Don't write it as 2x times 3y squared. Okay, 6xy squared. Square the last term. Don't forget to square the 3. So remember, square the first term, change the sign, the product of the two terms, square the last. 2 times 3 is 6 times xy squared. Number 5, x cubed plus 2. I do have a multiple of 3. 2 is not a perfect cube. 1 cubed is 1, 2 cubed is 4. I just passed it. Does not factor. Again, no irrational numbers when we factor. The worst that we're willing to look at are fractions, and we haven't had any of those yet. I'm trying to avoid them myself. Number 6, I have 2x cubed plus 2x squared minus 2x minus 2. I think they have 2 in common. So I factor out the 2. So I'm left with x cubed plus x squared minus x minus 1. I've got 4 terms. I'm inclined to do the grouping by first 2, last 2. So I've grouped the first 2 I grouped the last two. Okay, now staying inside the brackets, the first two have x squared in common. That'll leave me x plus 1. The last two, because that's a minus, I take out minus 1. And that's all I can do. If I take out minus 1, that'll leave me x plus 1. Inside the brackets, I have x plus 1 in common. It'll leave me x squared minus 1. Okay, now don't lose this 2. So I'll have 2 times x plus 1 times x squared minus 1. A difference of squares. So I can't stop here. So I'll have 2 times x plus 1 times x plus 1 times x minus 1. Now you could stop here, but the wise algebra student would write this as x plus 1 squared. So I'll have 2 times x plus 1 squared times x minus 1. There's the complete factorization. Okay, now again, sometimes they just love to factor all day long. Let's take a look at one more. I've got x to the 9th minus y to the 15th. These exponents are in fact multiples of 3. It's the difference of cubes. So the first factor, divide those exponents by 3. X cubed minus y to the 5th. Okay, now remember, this factor, second factor, is coming from the first one. Square the first term. X cubed squared is x to the 6th. Remember, power to a power multiply, 3 times 2 to the 6th. Change the sign. Do the product. X cubed times y to the 5th. Then square the last. Y to the 5th squared is y to the 10th. Okay, if nothing else, at least check the first two and last two. X to the 3rd times x to the 6th is x to the 9th. Y to the 5th times y to the 10th is y to the 15th. Okay? It's the cubes that's the hardest for people to recognize. For some reason, students always think that when they see a cube, they'll write down immediately that it will not factor. That's the end of section R.4.